name is Osama. I'm an educator here at the Science Center, and we are going to do a very cool demonstration that's going to demonstrate three very cool things in chemistry. Utilizing catalysts to create a chemical reaction that results in an exothermic reaction. So, you can't really try this at home because it could get a little messy and a little dangerous, but we have some things that you've probably heard of. We've got some hydrogen peroxide over here. Now this is the strong, nasty stuff. You probably don't want to put your hands in it. That's why we have all these safety shenanigans over here. And then we've got some potassium iodide, which is basically a salt. And it's really non-toxic, kind of looks like a salt in crystalline form. And what I'm going to do is, first of all, I'm going to dissolve my potassium iodide in some water. This is about 10 milliliters of water, just normal tap water, nothing special about it. And as we actually start to dissolve it, you might see a little bit of condensation forming on the beaker over here. If you can actually feel it, it's a little bit cold, and what's actually happening here is a little bit of an endothermic reaction. It's absorbing a little bit of the heat out of the environment to dissolve. And now this is where the fun stuff happens. We're going to put our funnel inside this stuff because science can get very exciting and messy. And then once I put my potassium iodide in here, we end up with a nice exothermic reaction, and all this gas that comes out, which is actually water vapor, and we have some gas trapped in those bubbles, which is basically oxygen being knocked off all that hydrogen peroxide using the potassium iodide. And if you actually put your hand right on it, you'll feel that heat evaporating off of it. And that's chemistry.
Hi, my name is Tony. I'm one of the educators at the MiSci Science Center. Today, part of our Fizz science, we're going to do a really cool demonstration with an explosion. And it basically, we're going to have a reaction between fire and flammable vapors. And that's being provided by this alcohol. So what I want to do is I just pour a little bit of alcohol inside this empty container. And the reason I'm using alcohol is because it evaporates very quickly. Those flames or vapors are very flammable. What I want to do is I want to coat the inside of this container. And so you lie in there and coat it, but I want to drain off the excess alcohol. I don't want too much. Now, the reason because I'm working with flammable fluid, I have my fire extinguisher and my safety goggles for protection. I'm also wearing gloves. Now, this is something you should not be doing at home. Okay. That should be enough. Now, I'm going to put on my goggles. And again, I have my fire extinguisher nearby. I'm going to light this vapors, this lighter. Watch. Isn't that cool?
At the Michigan Science Center. And for our Fizz science demonstration, we're going to be seeing if this food coloring mixes better with hot water versus cold water. So I'm going to use the hot water first and then the cold water. So here's our hot water. Let's mix it in there. And now for our cold water. So as you can see, our hot water, all the water already looks blue. And the reason why the food coloring spreads faster in the hot water is because the molecules in the hot water are more active. They're moving around. And there's more space for the food coloring to get all over. In our cold water, the molecules are not as active. They're condensing together because it's cold. And there's less space for our food coloring to make its way through the water. And that's why it spreads faster in the hot water versus the cold water.